Okay, I'm going to go over part 1 of the limits test, and this is going to be form A. So if you have a different form, notice your multiple choice answers will be mixed up, and the order of the questions are mixed up, but all the numbers and questions are the same. So just find which question I'm on and where it is on your test. The first one said that a function is reflected across the x-axis. When you reflect across the x-axis, right, over the x, what happens is the y value becomes negative. So that f of x part, the f becomes negative. Then when we shift something 3 units to the right, we subtract it to x, directly to x. And so both of these are happening, and that's going to match up with the letter C. Alright, on number 2, we have the limit as, this should have been an x, approaches negative infinity, and we can kind of rewrite this as the limit as x approaches negative infinity. We're looking for our highest exponents, so of 12x cubed divided by negative 2x squared. If we notice, the numerator is bigger, so it's going to go to either infinity or negative infinity. And if you plug in negative infinity, that's 12 times negative infinity cubed divided by negative 2 times negative infinity squared. So that becomes negative 6 times negative infinity cubed would be a negative infinity, right? Or negative infinity cubed, right? And then negative infinity squared is positive infinity squared. And you can cancel that out. Negative 6 times negative infinity is positive infinity. Alright, number 3 says for what values of x is f not continuous. So when a graph is not continuous, right, one of those here could be like you have a jump, and that's the most common thing for a piecewise is you'd have a jump. If it is continuous, then you'd have a hole there, but then from the right side it would go to that same spot, and so that would be continuous and not continuous. Basically what you're doing is you're checking if the y values are the same from the left and right side. So I'm going to plug in my x, right? If I plug in 0, so let's check 0 first. So at x equals 0, sine of 0 is equal to 0. A lot of people thought it was equal to 1, but sine of 0 is 0. And then 0 squared is equal to 0. Those y values are the same, so it is continuous here. So that means anything that has a 0 in it, any answers that have a 0 in it, we can cross out. So now we're down to just 2 answers. Let's check x equals 1. So we're going to plug this into x squared and into 2 minus x. 1 squared is equal to 1. 2 minus 1 is also equal to 1. So this one is continuous. So we can cross out letter B. We already know the answer is C. But just to show you, if we plug in x equals 2, we get 2 minus 2 is equal to 0. And we get 2 minus 3 is negative 1. So that's not continuous. Alright, next case it says that the limit as x approaches a is equal to f of x is equal to L, which is a real number. It says what must be true. So does f of x have to be continuous? Well, there are cases like this, right? Where maybe the actual value exists down here. This is from the left side and the right side, we could call that L. So as we come out from the left side, right, we'd be getting closer and closer to that L. From the right side, we'd be getting closer and closer to that L. But it's not continuous. So there is a case like that. Same thing for defined, right? Well, what if I just never filled that in? Then x wouldn't be defined here at a. So it just wouldn't be defined. But the limit still does exist. Does f of a have to equal L? Again, f of a here doesn't equal that L. You could plug it in down here, or it could just be dne if it didn't exist. So it doesn't have to equal L. And then f of x is discontinuous. Well, it doesn't have to be discontinuous, right? You could have a function where it's just continuous, and at a the limit is equal to L. So we're just trying to disprove these because it says which must be true. So actually none of those has to be true. Each of them could be true, but they don't have to be true. Alright, next question. It says we have the position of a particle is equal to negative 5t squared. Right, that's like our y value is negative 5t squared. And then it says the average velocity. Remember, average velocity is the average rate of change of the position. So that's f of b minus f of a divided by b minus a. And in this case, that'll be f of 3 minus f of 0 divided by 3 minus 0. If we plug in 3 there, that's negative 5 times 3 squared minus negative 5 times 0 squared divided by just 3. Negative 5 times 3 squared is negative 5 times 9, which is negative 45. That's going to just be 0 divided by 3, which is negative 15. Alright, next, this limit, we just plug in x is equal to 3. That gives us 4 times 3 is 12 minus 2, which is going to be 10. Right, in this case, if you plug in 4, you get 0 divided by 0. But we can factor out the denominator, so we're going to have the limit as x approaches 4, x minus 4 divided by 3 times x minus 4. That's 1 over 3, so that limit's going to be 1/3. Alright, this case, coming from the left, if you graph this, right, when you graph this absolute value, basically, if you think about our piecewise, it would be negative x minus 5 over x minus 5, which is just negative 1 coming from the left of 5. And then it's positive 1 coming from the right of 5. And the reason why we know it changes at 5 is if you take the inside of that absolute value, set it equal to 0, you get 5. So our limit coming right from the left side, because it says x approaches 5 minus, it's getting closer and closer to negative 1. If it had been the limit coming from the right side, we would have had positive 1. And if it had just been the limit as x approaches 5, since there's a jump and it's coming from different sides, it would be dne. But this was left, so that's why it's this negative 1. Alright, next. This one, it says as x approaches 3, right? So we're going to check this part and this part. So as x approaches 3, the limit as x approaches 3 from the left side is going to be this number 3. So it's going to be equal to 3. And the limit as x approaches 3 from the right side of this will be 2x, right? This right part. We plug in that and we get 6. So they're not equal, so this number 9 was dne. Alright, number 10. This is kind of a tricky one. This was really kind of tricky. But I said the limit as x approaches 2. Now notice a lot of people tried to kind of come here and plug in 0, but this is the limit as x approaches 2. And if we plugged in 2, right, that's going to be when x is greater than or equal to 0. So really all we care about is this side. So of 1, and that's just going to be equal to 1. Alright, number 11, if we plug in 4 to x, we get negative 3 times 4 divided by the absolute value of 4 minus 4, which is negative 12 divided by 0. We know this could be either infinity, negative infinity, or DNE for our limit. So we check a number that's just slightly bigger than 4 and slightly smaller than 4. Well, if you notice there's an absolute value, it's always going to make that 0 positive. So you can plug in the numbers, but that absolute value tells me it's always going to be positive. Now, I circled positive infinity, but actually I messed up because we have negative 12 divided by positive, so this is actually negative infinity. So if you plugged in a number just bigger than 4, you'd have had negative 12 divided by like the absolute value of 4 minus 4.01. Right, that's negative 0.01, but absolute value becomes positive. And then if you plug in a number just smaller than 4, like 3.99, you get 0.01 absolute value, it stays positive. So that's why negative divided by positive is negative infinity. Right, in this case, x approaches infinity. We see that the numerator is bigger, so we plug in infinity there. It's like having negative 3/2 times infinity, which is negative infinity. Alright, number 13, we're going to check just these biggest exponents. So that's like having negative 3x squared divided by negative 4x cubed. The denominator is bigger, so the limit just goes to 0. When the denominator is bigger, it's always going to 0. 14, we check our biggest exponent, which is 7. So this is like having the limit as x approaches infinity of negative 5x to the 7th divided by 3x to the 7th. And so we get negative 5/3. And then 15, we check our biggest exponent is on the numerator. And you could actually rewrite this as the limit as x approaches negative infinity of, if you combine like terms, negative 5x cubed divided by, and we only care about the biggest exponents, so divided by negative x. And then if you notice, the negative signs can cancel out, and we can cancel out an x to make that x squared. So if we plug in negative infinity, that's 5 times negative infinity squared, which becomes 5 times positive infinity, because when you square something, the negative goes to positive, so this is positive infinity. Okay, let me know if you have any questions on this, and good luck on your retakes.